Hi everyone, this video for calculus covers the last section, section 12 of the summer review packet. In this section, you're asked to sketch the graph of the parent function and then state the domain of the function. And number one, we have an absolute value function, and hopefully you recall that is a V-shaped graph. So absolute value has a hard turn there, just a V-shaped graph. When we're asked to state the domain, we need to think of all possible values of x that can be used. So there are a couple different ways to write this. So the domain can be written simply as all reals, like the capital letter R with that funny line there. And that means all real numbers. In calculus, we're going to focus on interval notation. So we want to make the transition from writing it in that symbolic form to writing it as the interval going from negative infinity to positive infinity with parentheses and not a bracket. Okay, so number 56, we have x squared. It's a simple parabola right there centered at the origin. So its domain, again, would be all real numbers. And we want to stick with trying to do interval notation. So negative infinity to positive infinity. So basically every value of x could be used. Y equals x to the third. That's a cubic function, third degree polynomial. So it's like an S-curve, comes down through the origin, rises to the right, falls to the left. Its domain also will be all reals. So again, we're going to give that negative infinity to positive infinity. Number 58 is a little different, so put a little asterisk there because the domain finally will not just be all real numbers. This is an inverse function, and when we graph it, we get two pieces, right, two curves. This function is undefined when x is equal to 0, so we would say x is not equal to 0. So the domain for this one, you could say it's all reals except x equals 0, okay? Or in interval notation, again, this is what we want to practice. We go from negative infinity to 0 with a parenthesis, and union with the other set from 0 to positive infinity. Again, parentheses because the 0 is not included in the domain. Right, number 59, we have a square root function. In order for this to be defined, x has to be either 0 or a positive number, and its graph looks something like that. So this domain could be written as all reals or all real numbers such that x is greater than or equal to 0. That's a greater than or equal to sign. But in interval notation, it's going to be a bracket, 0, comma, to infinity, because this time 0 is included. All right. And then our last one, the cube root function. So the cube root it goes something like this, right? Cube root function. So x could be positive, could be negative because it's an odd root. So we're back to having a domain that's all reals, or again, in interval notation, it would go from negative infinity to positive infinity. So again, I want you to get used to that interval notation. It's what we're going to use in calculus this year.